All right, so to, to show you guys kind of like how I want the class to go, I'm going to show you how I'm doing it with the pre-calculus class. So the pre-calculus class already has some assignments down. Now this doesn't mean we're doing extra assignments. It's literally all of Admentum. I'm just kind of pacing you guys because you know how sometimes you don't know what to work on and you don't have goals and stuff like that. So what I've done for my pre-calculus class is they'll have due dates and stuff, and this is literally the just the times or just the scores they're getting on Admentum. I'm not grading it differently. I've already, for example, like I've already messaged these two guys about getting their mastery test done. So it allows you guys to be more accountable. That way, you guys can have someone else besides your independent studies teacher going like, "Hey, what work are you going to turn in?" I can be like, "Hey, I notice you're going a little slower on your math. Like, let's try to, what can I do? Can we set up an appointment? Like, what can we do to help you with the math?" And what I also do is I post videos on YouTube. So this one, for example, is a video of when we did the module exponential functions. And usually it takes for calculus, it does take a little longer, so that's why they're usually done in parts. With geometry, I'm going to try to do it one part. Just one video is going to be the entire module. That's it. So they can see it on the Google Classroom. So if you guys haven't said yes to the Google Classroom, just let me know if you need help with that, and I can show you guys how. So this is on the Google Classroom. It's the YouTube video. But what you can also do is you put watch on YouTube. Let's say you just want to lay down and just watch this on your phone. I actually have playlists here for all of the pre-calculus Admentum videos. So I'm going to do the same thing with geometry. There's going to be a video of this class session. Hey, how's it going? There's going to be a video of this class session on here. So like let's say you missed the first part or you're sick, you missed the first day or something like that. You can go onto YouTube, watch this, or if you just want it nice and organized for you, like you don't want to save this as a bookmark on your phone to watch it, what we can do is you can just go to the Google Classroom. You can even have the Google Classroom app and just watch that class section. So if you know like it's a section that you want to go back, you're like, I know he said it during class, I forgot. You you can always just go back to your Google Classroom. Oh, this is the algebra one, not the geometry one. Algebra hasn't even started yet. Um, Also in the Google Classroom, you'll see I'm gonna keep this on the top as much as I can. So as I post different things, I'll move down, but I'll keep moving it back up. This is my Google phone number. So you can text this, you can call this, although usually I'm busy, so you'll probably have to leave a voicemail. Send a text, send a call, you know, just to get a hold of me. I recommend doing the remind because this is how I'm going to let you guys know, like, hey, this assignment's due. It's more for class wide things, whereas I'm going to send texts more personal, like, hey, you missed this, and I don't have to like send it out to the whole class. I just think it's easier, because then you can call me. You can't call me with remind, you know. And I don't know if you guys, your teachers have shown you this, but this is my appointment link. So unlike your independent studies teachers where you have a specific appointment, with me, you can make an appointment at any time that like it's available. So for example, if we look here on Thursday, people have already signed up for appointments, and in the morning from 9 to 10, obviously Tuesday Thursdays, if I go to like a Tuesday Thursday, what's going on? Oh, I guess people have signed up for a lot of them. um, you'll see that there won't be times on Tuesday Thursday. So what's going to happen is as these appointments fill up, you won't be able to sign up for them. So this is just in case you're like, that class was good, but I didn't understand, how to make a circle on GeoGebra. Just make an appointment, or let's say you kind of want to do some more review. Make an appointment. It's for 30 minutes. All you do is you click your time, confirm your name, student email, and then why you're meeting with me. So obviously, like if you need something like with GeoGebra, just say GeoGebra geometry help or something like that. Click schedule. What'll happen is it'll make an event on Google Calendar, calendar.google.com. It'll make an event here where we'll be meeting with each other. And then it'll make a link. So you go to your you go to calendar.google.com. You don't have to type in this extra stuff here. Just calendar.google.com. Click on the appointment. So let's say I wanted the geometry cohort. Join the cohort. That's it. Or let's say I'm even lazier than that. I'm like, I just want to see my appointments for today. Meet.google.com. Boom. All your appointments for the day. This will even show your teacher's appointments for your IS teacher. There is there any questions on like how it's gonna work class wise or anything like the structure? All right, cool. So the main thing we're gonna do in this class, so that was just basically the intro. I actually like how geometry's set up because geometry is different than your other math classes. Um, So they actually started off with an introduction to what geometry is and how it works. So usually when we start class, I'm going to skip the intro videos, mainly because it's usually just to show you what Admentum is. You know, you guys can watch that on your own if you want. Um, I recommend it for not necessarily the intro videos, but more for like the summary videos and stuff like that. Because I'm not gonna sit here and just play something for all of us to watch together. I want this to be more for questions, you know? So let's get into the lesson today. Also, I've noticed a lot of students have their slide narration on and then they just hit the pause here. You can turn that off here. I just wanted to let you guys know that because a lot of people, yeah, just click this, make sure it's off, and it'll be off forever. Like that way, that way you don't have to be like, pause. I had one student tell me like, oh, um, that kept waking up like my family every time like I wanted to work late at night, and it's like so. And your calculator stuff is here for when you're studying the tutorials in case you need to like do stuff. There's not going to be that much math here. I'm a little annoyed because normally there's a highlight feature here and there's not this for this lesson, and this lesson has a lot of highlighting. But if you guys ever need help understanding how to do Admentum and stuff like that, let me know. Schedule an appointment with me or just send me a text and we can talk about it. So no problem, man. So right now we're just going to talk about what geometry is. So geometry is just this idea of relationships among points, lines, planes, figures. I mean, it's basically what you think of when people are like, "What's the area of a circle?" Stuff like that. Um, and this introduction actually gets into like careers and stuff you can use for it. But one of the things that I think people don't take for granted with geometry is it's a logic based system. So what it means by that is what I like thinking about it is it's kind of like when you write an essay. Like I don't know if you guys have had a class with Mr. Josh yet, but you know how you have to like state a fact and then give your supporting argument? It's kind of like that. You have to state a fact and give an argument. And that's going to go into proofs and stuff later. So so history of geometry. So geometry actually extends from Greek, the word geo meaning earth, and metron meaning measure. And the idea of this is back in the day, they used this to measure land. So that's how it was back in the day. And the study of geometry is like really, it's a really old type of math. Like, I don't know how much you guys know about old math, but back in the day, um, they didn't really have numbers the way we think of them with fractions and stuff like that. It was very different. Like it was mainly due to like, oh, let's kind of like build something and measure it as best we can, and that was it. So when geometry came around, it was literally just for building stuff. It wasn't necessarily for like you take a class and you learn it. It was a higher form of geometry. So this happened with. It started with the philosopher Thales, and normally, guys, I don't get into like the history that much, but literally the module test, the mastery test for this is all history. So yeah, so I know it's kind of boring, but yeah, this the whole test for this module is that. So it's gonna start with this guy, Thales. I never know how to pronounce the Greek names. And also in Greece, the Pythagoras society. This society was dedicated to making the formulas and stuff in geometry. That's where the Pythagorean theorem comes from. It's from this society right here, the Pythagoras society. And it says so right here. The Pythagorean theorem, probably learned in middle school. And one thing that's funny is a lot of people think this is literally just for triangles. If you ever get into like video game design or physics and stuff like that, this is actually an important thing that you'll learn because this can not be applied to just shapes. It can be applied to forces. Like let's say you're running this way and this way. Well, it's faster to run this way. So it's like at what rate do you have to run this way to be just as effective as running this way and this way? So that's the way I see it. There's more to the Pythagorean theorem than just shapes. Shapes are the only ways we can see it. So later on, if you guys ever take like more advanced studies, when you're studying like physics and stuff like that, shapes are how you draw it. It's not but force. Like let's say if someone hits you this way and someone hits you that way, you're gonna go diagonally. So that's how we do it. That's how geometry is used, is more to kind of shape it out. And one of the guys that did kind of the most work of geometry is Euclid. So this guy wrote like literally books on geometry. Those books are called the Elements. And he started this around 300 BC. So he wrote, oh, here it is, 13 books. He wrote 13 books and he called it the Elements. So this guy's kind of like the father of geometry. He's what you think of. If you think of shapes and stuff like that, this guy's the one who like defined what a triangle is, like how you can draw what a circle is and stuff like that. And he introduces these terms. So these terms, I think they talk about it later. They're um, in this. It says it later on the slide, but these terms, a point, what a point is, what a line is, what a plane is. He's the guy who invented what these are. So when you're doing algebra and you're trying to figure out what a point is or how to calculate a line, he's the guy who did this before like X and Y and all of that. So, and you'll have questions like this on your mastery test. So, like I said, this introduction doesn't have a lot of math, but okay. So, what was the name of the trustee in which Euclid compiled his existing works, knowledge, above observations? So, this is the Elements. That's the book that he wrote. So, he wrote in 300 BC. Did you have a question? Sorry. It's 13 books. Yeah. So he wrote in 13 book trustee, but I think nowadays it's like in one book. But it probably is. I think it is on the test. Yeah. So a lot of the stuff I've been highlighting, FYI, in case you guys want to watch the video, it is kind of involved in the test. So when you see me do this, it's probably a good thing to write it down or something. um, no problem. So yeah, so the Elements is that book that he wrote. So when you guys are doing the tutorial, remember you have to complete the tutorial in order to finish up your unit. Now you guys know the answer. So the reason why the teachers are so liberal with me doing the tutorials is it's not graded. This is just a good way for you guys to know the information and get someone. Now's a good time to like ask questions and stuff like that. This one not so much because it's literally you guys listening to me talking and summing it up. But yeah. So the structure of geometry is what's known as an axiomic system. So this system's kind of important because it's the idea of what we build upon. We're going to do a lot of axioms and stuff like that. And these are known as undefined terms. So undefined terms are those things that I talked about before. They're the line, they're the point, they're the plane, and Euclid defines all of these. Um, theorems. Theorems are statements of truth. So that's where I was talking about before, where you have to state a fact and you have to state your reasoning. So theorems can be proven using logical facts. So that's where geometry is based off of. You can pretty much solve any problem in geometry so long as you're backing it up correctly. So one proof from someone might not look like another proof from someone else because the way you think about it might be different. And that's what's kind of cool about geometry. So these are um, the axioms that Euclid built all of his studies on. So one of them is any 2 points make a line. So any 2 points, if I have 2 points, I can draw a line right through them, and there can only be one line that goes through them. There's no way you can draw a line and it go through B. It has to be this way. So let me turn my pen on. So for example, like obviously if I go like this and then go back down, that's not a line anymore. And what's interesting is later on we go over how this is always the shortest point. There's no way you can like do this and that and it be shorter distance. The shortest distance between 2 points is always a line. The distance postulate. So this is just saying how we can determine the distance between that. And oh, I didn't realize we are going to do that far. So this always has to be a positive number. So let's say if we have like an A here and a C here, we don't call this -2 like we do in algebra. This is just +2. It's always the absolute value. And the ruler postulate says that we can start off at any point. Like we can call this 0. We can start, I'm going to start measuring from here. But let's say it's like, we don't want to measure from there. We want to measure from over here. Then we can call this 0, too. So that's basically that's the ruler placement postulate. Sorry, I was talking about this one. I get these two mixed up because they both have this ruler and postulate in there. Ruler postulate just means that, where is it? That everything in between there has real numbers. So this ruler postulate involves real numbers. So that's what this means. It just means that we can't do something like, we just can't make up like an imaginary number in there. There's a bunch of numbers in between 2 points. Like there's fractions and stuff like, so that's what the ruler postulate says. Ruler placement is what I was going over earlier, where it's like, I'm going to call this 0 and I'm going to measure this is from here to here. That's all ruler placement is. And then let's go over the other ones. The definitions of lines and planes are important. So whenever you think of a plane, think of like a piece of paper. A piece of paper is a plane. It has 2 dimensions. You can go left, up and down, diagonal. And what Euclid says is you need to have at least 3 points to make a plane, which makes sense because you have to have the up and down and everything. They also have to be non-collinear. Non-collinear just means they can't be on the same line, because obviously if they're all on the same line, same straight, let's pretend this line's straight, that just means that you just have a line. You don't have a plane until you have 3 points that aren't on the same line. Okay, so 2 points, line, same plane, and 6 just kind of says that if 2 points are on the same line, they have to be on the same plane. Well, that makes sense, because if you have a piece of paper and you draw a line, the line's not somehow outside that piece of paper. It wouldn't make any sense. So Any 3 points more make a plane. So that, like I said, is obvious. Um, Intersection of 2 points. Oh, this is interesting. So if you have a piece of paper and then you have another piece of paper that somehow you get it to cross through it, the points where they cross each other makes a line. So that's just saying that if you have two pieces of paper, it makes a line. I know this picture is really bad. I'm not the best artist, so sorry about that. You guys are going to have to deal with my bad drawings all class. All right. So, which statement is not one of the axioms of Euclid? So, this first one says if 2 points lie in space, there is exactly one line that passes between them. And we already said that's true, right? If 3 points lie on the same line, there is only one plane that can pass in between them. So that one kind of doesn't make any sense, right? Because let's say we have 3 points. We could have a piece of paper going this way. We can have a piece of paper going this way, and they both contain them. So this one's a little questionable to me. 2 points on a line make a plane, also contain the points on. We went over that. If you have a line, obviously it's on the same sheet of paper. If 2 points intersect, it makes a line. That was one of the last ones we did. So the only one that doesn't sound like it's one of Euclid's axiom has to be this one. All right. And they actually go over it in a little more detail. They're like, there's actually a bunch of planes that can go through it. Because I only went over two. There's also like all the diagonal pieces of paper that can go through that line. So this one kind of talks about the careers. This is why I started mentioning computer science and things like that you will have more careers for. Normally for the activities I will go over. However, this has to do with a lot of your own words. So for this, you have to kind of click this link over here, careers, because this is talking about the roles. So you'll click this, and there's a YouTube video also where he kind of talks about it as well. But most of the reading you're going to have here. About transportation and stuff like that. And obviously, if real transportation people do it, then if you're designing a video game, you have to do that as well. If you're just making a city plan, you will have to do that. So I don't think they talk about city planners directly and stuff like that. Oh, aircraft designers. So you guys can read this and then just write about what you think requires geometry. What's interesting is when I was reading this, is medicine. And I was like, how does medicine? But they talk about it's like ratios and proportionalities. And that's one thing I didn't think about. So we'll go over later how, like, if you have a small triangle and then you have a bigger triangle, everything in this triangle becomes bigger. Well, except for the angles. But that's what it means. Like, you do kind of use some of these ideas that started off in geometry. Like, now there's different, like, there's algebra and stuff like that, but it did start off in geometry. This idea of fractions and stuff like that did kind of start off from what we learned in geometry. Engineering, obviously, you would need engineering. You would need to learn the shapes, physics, and all that. So yeah, that one, just read it. Write about the careers you can do on it. If you need help with it, I can help you guys out with it. But normally, like I said, we'll try to go over these. But since this one's so much of like your original work in your own words, I can't really like go over it in too much detail. Ba, ba, ba. So then some people who study geometry, academic. So obviously, like, for example, me, I took a few classes in geometry and like I'm teaching it. So obviously teachers do it. Physics uses it a lot. So that's why I always talk about physics and stuff. Architects, medical fields. And the reason why they do go, I'm going over this a lot is because there are questions about careers with geometry. Blah, blah, blah. And then summary. Normally, I like the summary section. I mean, this one's still pretty good too. But this section is not something that I want you guys to just skip when you guys are like studying, especially for other classes, because this usually has a lot of information that's on the test. So never underestimate the slide or the summary video at the end of a section because it just has so much information you can use. Do you guys have any questions about the class today?